Hello everyone, hopefully you're doing well. This video is going to go through a reminder of some things about factoring. For factoring, what we're doing is we're taking polynomials and turning them into smaller pieces. So we're trying to take something and what we're going to focus on is something that's got a degree of 2 and break it down into its smaller pieces, its linear pieces. How we do this will depend on what numbers are in this problem. So we're going to start with some of the earlier examples where if we're thinking about a quadratic in terms of ax squared plus bx plus c, when thinking about when a equals 1. All we're in charge of really to do this is we're looking at our constant, our c value, and we'll be looking at our b value, the number in front of the linear term. And what we're trying to do is solve a little puzzle here that says what two numbers multiply to -32 and add to -4. Now, depending on how good you are with your times tables, your division ideas, this might take a little bit longer, a little bit shorter. But those numbers are going to be -8 and 4, because when you multiply them, you get -32. When you add them, you get -4. And when a equals 1, those are the numbers that we are going to use to factor. So we break it into two factors, where we know that x times x has to be x squared. That's why we know those x's have to be there. And then we're going to use that -8 and that +4. So this thing factors to x minus 8 times x plus 4. Looking at these middle terms to make sure they add up to that -4, -8 times this x is -8x, this x times that 4 is 4x, and -8x plus 4x is equal to -4x, which is that middle term that we're hunting for. On the next page, on the next example, we got some bigger numbers. So what do you do if you look at 156 and you're like, I have no idea what numbers to even begin with? So I've got this calculator thing up here. You really do have to think about what numbers could you possibly know that multiply to 156. And if you really have no idea, I've got something for you to try that can get you somewhere. I always like to go through all the numbers starting at 1 and say, is this a factor of 156? And 1 always works because it's always 1 and the number itself. And then I move on to 2. And if you're not really great with multiplication / division in your head, you go to your calculator. 156 divided by 2, that's 78. So 2 times 78 is 156. And then if you ask yourself, is it divisible by 3? And if you can't do that in your head, you go to your calculator and it looks like it's 3 times 52. That is 156. And then we just go through all of these numbers. So I try 4, which is 4 times 39. That's 156. Now, you might know to skip 5, but if I try it in my calculator, I get a decimal. It's not part of our factor list. So I move on, and I keep doing this until 6 and 26, until this list kind of curves, or I guess wraps around itself. 156 divided by 7. That gives a decimal. I'm not going to add it to the list. Oops. 156 divided by 8. 19.5. Don't want the decimal. Divided by 9. Another decimal. I know 10 won't work, but I'll show you it doesn't work. 156 divided by 11. Still a decimal. 156 divided by 12. We get 12 and 13. Now, how would I know I'm done here is because the next number I would try after 12 in this little division thing here would be 13, but 13's already on our list. So I know I'm done. Now, what we're trying to do is look for two numbers that multiply to 156, which I just made that entire list over here on the left. And now we have to find the numbers that when we add them, you're going to get to -25. So you look at this list and you think to yourself, which of these pairs makes me think about 25. Really -25, but let's just start with 25. 1 and 156, no. I kind of look through these. I'm not getting the idea of 25 till I look at 12 and 13. 12 times 13 is 156. 12 plus 13, that's 25. we don't want 25, we want negative 25. How do we make that work? Well, if we make everything negative, that will change this. So our two numbers are x minus 12 and x minus 13. There's the long way right there. Looking at our next slide, which shows the answer and shows you when we multiply the inners and the outers, they add up to get our middle term. Now, what do we do when a, remember the number in front of x squared, is greater than 1? Well, first things first, you should always, always, always think about a GCF. I look at this 5 in front and I ask myself, is 5 a factor of everything? And in this case, the answer is yes. You can take a 5 out of everything. So think about dividing a 5 out of everything. If we take the 5, if we factor out the 5 out of 5x squared, we're left with x squared. If we factor out a 5 out of minus 60, we get minus 12. So we're left with minus 12x. And then 540 divided by 5, if you can't do that one in your head, you go to your calculator, you type it in, and you get 108. With our factor of 5 out front, we now go back to what we did for the previous two problems. And you might look at 108 again and say, well, I don't know what numbers multiply to 108. So we go through that whole process, which I'm going to try to type really quick here. Just get a couple done before I start writing, because if I type more, this might go a little bit faster. So divided by 5, that won't work. So we got 2 and 54, we've got 3 and 36, we've got 4 and 27. None of those look like they're making me think negative 12 yet. 6 and 18, ooh, there's a good one. 6 and 18, those are 12 apart. Maybe those are the numbers we're looking for. If I take 6 times 18, that's 108, but we want a negative 108. So something has to be negative. And if we want this to add up to negative 12, well, I think that would make the negative go in front of the 18. So what does this factor to? We're going to have a positive 6, so x plus 6, and then an x minus 18. With the 5 out front, because we factored out the 5. All right. Now, what happens, folks, when the number in front of x squared isn't 1 and there is no GCF? That's on the next problem. 3, 10, and 3 are the numbers that I see, and 10, unfortunately, is not divisible by 3. So you might remember doing this previously. We see that 3 out front. 3 is a prime number. The only things that are going to multiply to 3 are 3 and 1. So we kind of just know that the first two terms have to be a 3x and an x. When we multiply those together, that's going to get us our 3x squared. Now in this problem, 3 is our last number. And we kind of think to ourselves, we already had this thought, the only numbers that multiply to 3 are 3 and 1. So these are the numbers that we kind of have to check to see which gives us the proper term in the middle. We're looking for 10x. Ooh, I wrote those two backwards on the other one, because if I put 1 in the first one, then I have to put 3 in the other one. If I put 3 in the first one, I have to put 1 in the other one. So if you don't know, it is just simply at this point guessing and checking. Is it 3x plus 1 times x plus 3? Is it 3x, oops. Is it 3x plus 3 times x plus 1? Now there are some ways you can know which is which, but realistically right now, remember, all you're doing is you're checking those middle terms here. For this first one, 3x times 3, well, that's 9x. 1 times x, that's 1x. And when we add those together, we get our 10x. So I got lucky. It was the first one I wrote down. If we checked the other one, just by the way, 3 times x is 3x. 3x times 1 is 3x. When you add those, you would get 6x. So if this thing up here would have been 6x, it would have been the second one. But there we go, 3x plus 1 times x plus 3. I've got one more here. And this one gets even a little bit more tough because if we look at the first number, 8, there's a couple possibilities. It could be 1 and 8 and 2 and 4. So we actually have to think about a few more possibilities. The first two terms could be 8x and x, or maybe they're 4x and 2x. So that's just more work added onto our plate of figuring this out. When we look at the last number, negative 21, I think to myself, 121, 3 and 7. So not a lot of choices, but with the 2 at the beginning and the 2 at the end, what could we do? We do have to worry about signs for this one. It's not all positive this time, so something is going to have to be negative in this case. But anyway, it could be 1 and 21, it could be 3 and 7, it could be 21 and 1, it could be 7 and 3, and those options kind of in both. We don't know which could be which, and at this point, it's kind of about you and like your number sense here about how to make this faster. If you think about our signs again, something has to be a plus, something has to be a minus, because that negative 21 means we have a positive number times a negative number. So 8 times 21, that's way too big. That's not going to get us 2. So I'm going to cross those out. 8 times 7 is 56. I don't think we're going to be able to get to 2 from that one. 8 times 1 is 8. 21 times x. 8 and 21, I can't get 2. 8 times 3 is 24. 7 times x is 7x. 24 and 7 can't get 2. So this is me running through doing some just general mental math about multiplying two numbers and thinking to myself, if I were to combine them through subtraction, could I get negative 2? And I have decided that no, I don't think the 8x and the x is the way to go. So I go over to my 4x and my 2x. I think 4x times 21, that's 84. I don't think I'm going to get to negative 2 if the 21's over there. 4x times 7 is 28. 3 times 2x is 6x. 28, 6. I'm not thinking negative 2 from those. 4 times 1 is 4. 21 times 2 is 42. 42 and 4. I'm not getting negative 2 from that. And would you look at that? Maybe it's our very last one. 4x times 3, that's 12x. 7 times 2x, that's 14x. I can think about using these two numbers and thinking about something being positive and negative to get negative 2. So it looks like our answer is going to be 4x and a 7 in the same factor, a 2x and a 3 in the same factor. And then thinking about signs, we want this 14x to be the negative one, because 12x minus 14x is negative 2x. So where'd the 14 come from? That came from the 7 and the 2 being multiplied. So the 7 has to be the negative one. Yuck. So you can see that answer under here. Now, if you want to stick around for a minute, I have one other way how to do some problems like this. I don't want to call it a trick, but maybe you'll think about it as a trick. Let's look at this 3x squared plus 10x plus 3 problem. Another way you could think about factoring this, actually, is multiplying the first number to the last number. X squared plus 10x plus 9. Now you factor this as if the a was equal to 1. So if we thought about this as 1x squared plus 10x plus 9, that would factor to x plus 9 in x plus 1. Now, of course, this isn't the answer. We know the answer over here is 3x plus 1 and times x plus 3. So how do we take this and make it look like this? Well, doing my way of this little trick, you take this very first number and you divide both of those terms. If you can simplify, you leave it. 9 divided by 3 is x. Or excuse me, 9 divided by 3 is 3. But if you get a fraction, you see this 1/3 that we can't simplify? Anytime you get a denominator, you have to simplify it. You can slide that denominator in front of that x. And there's another way that sometimes you can factor things when the a value is not 1. All right, hopefully this was a good reminder. Sorry for it being so long, and hopefully you skipped around and only watched the parts that you needed to, or at least made it faster.